5:35. Will that be all right?
Yes, that'll be fine.
That would be fine. Okay.
Yeah.
That will be a 15 minutes break for each person's editing. Okay, then
Yeah.
let's start. Okay. So what's with the data science? Like everybody in the world is talking about data science and wanted to go in the way of artificial intelligence, machine learning, deep learning, data science. And what do you think? What is the data science? Like whatever you know, you can share with me.
Sure.
What do you understand by
So,
data science? Yeah.
from common knowledge, when I think about data science, it's uh, data science.
Yeah.
So, is it like basically okay? How would I put data science? Sorry, let me just think. Data science.
Okay. Okay.
Um,
Okay. Let me put it this way. Can you tell me what is data? Data. What is data?
data. Okay, data is just basically like information that
Yeah.
is this is like small data that makes up a big pool of information.
Exactly, 100% correct. It's the information, like each and every one of us, and the customers, the employees, the products, the services, all have our own data. Let's talk about us, the people. We have our own data. If a company is maintaining a data for a person, he must be knowing it. The company must be knowing about the name of the person, about his age, about his gender, for which city he exists, and then the place, and the country, the state, right?
Yes.
What's his profession? So many companies have their um, are busy collecting the data for the databases, right? And each and every company right now, okay, and each and every company right now are moving towards the data science. Now, why they are moving towards the data science, I'll tell you. You must have heard about the clouds and databases, right? Okay, let me tell you what are clouds and databases. Clouds and databases are those storage devices which can be tangible as well as intangible, right? Tangible means
So, so you said it's like so cloud and databases. You said it's is it like a storage?
yes, yes, exactly. These are like the containers, storage containers, which contains all kinds of data in them,
Yes.
right? Right?
Yeah.
Okay.
Yeah.
Let's say we talk about Google, the Google Cloud. Okay. Now Google Cloud contains each and every detail, each and every data of a small species, from a small species to a big country or a big building. Um, um, each and every information about each and everything in the world, uh, and they are using artificial intelligence in their apps like Google Maps and Google Translator and
Okay.
audio processing, audio recording, natural language processing, and many other things, image processing. So all these are the parts of AI, artificial
Yeah.
intelligence. And I'm just talking about one company, Google, right now. Okay, so
Yes.
Google is maintaining a big database, a big cloud, is its own cloud. Now, the thing
Sorry, can
is,
you hold on for sorry, can you hold on for a minute? So just 1 minute. Hold on. So hold on 1 second. Just hold
okay,
on.
okay, okay,
Just hold on. A minute. Just hold on.
yeah,
What's this guy's name? Sorry. Hold on.
it's okay.
Hold on.
If
Sorry.
if you
Just hold
want
on
to,
a minute. I'm so sorry.
yeah,
I'm just about to just come. Give me a second. Just trying to change something on my computer. Yeah, Devin. Sorry, 11. Sorry, 15. Sorry, 11. 11:50. Sorry, hold on.
It's okay. You can complete that. We'll start.
Just give me 2 seconds. I'm almost. Sorry, just 1 second. I'm almost done. Sorry, just hold on a second. Sorry, hold on. Here we go. Here we go. All right, let's go. Sorry about that. Sorry. Yeah, I'm here. I couldn't hear you for a second, so I had to change the audio. Sorry.
Oh, okay. Can you hear me now?
Sorry. Yeah, I can hear perfectly.
Okay. Now we are good to go. Okay. So now Google is maintaining its own databases, having all necessary informations around the world. Now, the thing is, the smaller companies, let's say 20, 38 years before, some smaller companies wanted the data. Now what they will do, they will reach out to Google database.
Okay. So you're saying Google was where, what you saying, like, so basically you're saying Google was where data first started. Is that what you're saying?
What? Sorry?
Are you saying, like, is Google, you know how you're saying, like 20, 30 years ago that they will reach out to Google. So you're saying that Google is the beginning of how data information was stored. Is that what you're saying?
I'm just giving you an example. Like
example, okay.
A small example. It's 20 to 30 years. Let's say 10, 12 years.
Okay.
Okay. I'm just giving you an example. Like the companies which are newer, the companies which are smaller, the Google, they also needed the data. They will reach out to the Google databases. The Google will grant them the permission to use the data from the Google databases, and they will get some profit. They will get the profit out of it. Like the profit can be in the monetary terms. The profit can be in other terms as well. Like that could be anything. But mainly the profit comes in the monetary part, right? Are you getting it? Now,
yes.
Now all the companies are, in a way, they're planning to maintain their own databases, right? Now, each and every company, a company, let's say a Barclays. Have you heard about of the company Barclays?
Yes, I have.
Yeah, Barclays, Nestle, Cadbury, Samsung. So these are certain companies, and there are many thousands of companies which are now busy maintaining their own databases, so they don't need to depend on other companies, other big companies, to get the data. Now they're building their own databases in clouds. Are you getting it?
Yes.
So that's the thing. That's why each and every company are moving on towards the database. They just maintaining relevant data. Okay, let me tell you one thing. In the databases, in the big databases in the cloud, in these databases in the clouds, the data is not structured. It's a live data. It's not completely structured.
You said it's live data. Is that what you said?
Yeah, that's the live data.
So when you say live data, that means the data keeps changing.
Okay, that's a certain difference. There's a certain difference. Okay. Now, the thing is, there are certain databases, OLAP and OLTP.
OLTP.
Yeah. OLAP and OLTP. OLAP and OLTP. So, do you know about these things?
No, I haven't.
Okay. Say, OLAP is called online analytical process data. And OLTP is the online it's live data. It's actually OLLP or OLTP, transactional.
Online transaction.
online transactional data. Now, can you tell me like what would be the difference between online analytical data or online transactional data?
Okay.
Like, can you tell me the difference between just looking at the words?
Okay, so the difference between the online analytical data, process data, and the difference in online transactions. So, online analytical process data is maybe, so basically like analytics. You understand, like trends. That one is more based on data, based on trends. Online transactional data is maybe uh data that is based on like transactions. So maybe how much people purchase a certain item online. Do you understand? And maybe it could be broken down to days, weeks, months, in terms of how many people make certain purchases. So that it's translated into from information to data, from transactions to data, in terms of cash flow, in terms of how much money has been spent or how many people are purchasing certain items. So I think one of them is based on trends. One of them is based on calculating data based on cash flow, in terms of financial data, in terms of how much people are transacting.
Okay, I really appreciate that. You actually describe the words in your way, and I really
Yeah.
appreciate that you put up like you are up for it, and you put in an effort to describe this. Okay, let me tell you. Live data, online transactional data is the live data. Okay,
Okay.
transactional data which keeps on changing, which keeps on changing,
Okay. So transactional data keeps on changing.
keeps on changing. It's the live data. This is the OLTP. Are you getting it?
Yes.
Let's say Amazon. Okay, let's talk about Amazon. And Amazon is keeping something like what's going on? It's May data from May to May 23 to 31st May 2023.
Mm-hmm.
Okay. Now, in these days, in the month of May, there must be some online orders ordered, yeah, by the people. Okay, so
Mm-hmm.
that data is going in an OLTP database because it is it keeps on changing, right? So no analysis can be done on the changing data, right? That you understood from here.
Yeah.
Okay. So no data. Okay. So the live data is going into the OLTP databases. Now, because that's a live data, it keeps on changing. We cannot do any analysis until it gets fixed. Okay. Now,
Mm-hmm.
let's say we move on to June, May, June. Let's say we move on to the next month and say, okay, let's move on to the June and say, let's move on to the July data now. Amazon has marked each and everything about the May's transactions, and now they can say that nothing can be changed in a May's transactions. Like no orders can be
Mm-hmm.
returned, no refund can be done now, and each and every data has now been fixed, right? No change, no further changes can be done
Okay.
in the data. Okay, no orders would be
Okay.
returned now, no refund would be made now, and no changes would be done. Now that data is static. Okay, now no more further changes would be done. Now
Okay.
that data, which is an OLTP database, will be going to the OLAP database. Are you getting it? Now, what is OLAP database? OLAP is the online analytical processes. Or in the online OLAP databases, there is only static data, or we can say it's a historical data,
Mm-hmm.
and we always do the analysis on the historical data, right? I hope you get it.
Yeah, so hold on. So basically, OLTP is like, for example, as you made like dates. So they say like for the year of 2022, from January 1st to December 31st, for OLTP. So you're saying like it's static data. So maybe all the transactions that happened between January to December, you understand, that's been analyzed. That is like data
Yeah.
that is historic, that's in the past, that's static. That is OLTP. But for OLAP, it's data that maybe going forward it keeps like changing in the sense that is that what you're trying to say?
See, the live data is getting
Live data.
the live data is going to the OLTP databases, right? And
Okay.
in OLTP databases, because it's a live data, it will keep on changing, right? Now, until and unless the data in the OLTP databases gets fixed, until and unless it gets fixed, after it gets fixed, after now the company says no more changes can be done in that data is moved to the OLAP database. Now that's a historical data.
Okay.
Okay. No more changes can be
Yes, I
done.
understand.
Yes. So because the data was coming live in the OLTP databases, it was completely unstructured or not
Okay, I
clean.
understand.
Okay. Let's say, if an order is there, so it's an order ID, customer ID, customer name, and there can be many things like product ID. And if the customer has not mentioned the email, then that email data will be blank. Okay, are you getting it?
Yes.
Okay, let me show you on the Excel. Order ID, customer ID, product ID, customer name, product name. Okay, and there can be many things. What are these? What I'm writing? These are the variables. These are the features. These are the information.
Yes, correct. Correct.
This is the information, right? And a company needs to get the information of the customer so that they can use it in the future, right?
Yeah. Yes.
Yes. So that's the recommendation system for any company like Netflix. If the person has a or anything, HBO or Netflix or Amazon Prime and Sony Live, and there are really many apps which uses this recommendation system. Amazon uses it quite frequently, and now many companies are using recommendation systems, getting all the information, getting all the information. Okay, all the information in the sense that they want to get maximum information out of the product. For a company, the product is not only the product which they are selling. The product is also the customers, right?
Yeah.
They want the information of the customer. They want the maximum features so they can utilize it in the future to make certain marketing strategy, to make certain business strategies to get more profit in the changing times as the time changes. You know.
Yeah.
So there in the live data, there must be some things which are unfilled or which are kept blank. Let's say the company must be dealing with the email IDs and the customer has not mentioned the email IDs, the customer has not mentioned the phone numbers. And I'm talking about those companies which don't have much bigger websites. Although the companies like Amazon, they always want the email ID and phone first, right? To make a Amazon ID, like you must have made the Amazon ID. They must have asked you for the email ID and phone, right?
Of course.
Yes. So that's the thing. but there must be many features which you must have not filled, right?
Yes.
Like what could be those? Like what could be those? Any example you want to give?
So
Like
sorry, hold
anything.
on. Oh shit. So for example, so what is like for example like a movie? Is that what you're trying to say? Like a type of, is that what you're trying to say? Like a type of movie?
Like a feature, like an information which the customer hasn't filled. The customer is not interested, or it's quite personal, or customer want to keep it like private.
Okay, so maybe it's like so okay, basic when it comes to this, maybe like bank details, for example, like bank account number, card number.
Yes, yes, that could be something. Bank
Yeah.
account number. Um, okay, nowadays gender is also a very like people don't want to reveal the gender. Like there are certain options like male, female, and then there are certain sections of people which don't want to reveal their gender. So that could be a certain privacy. Like people want to keep it more private. Okay, so there are certain things, there are certain features which are left blank or
Mm-hmm.
which are not
Mm-hmm.
maintained correctly. Or there could be things that there could be wrong entries, like let's say in the customer name or in the product ID, by mistake a customer ID has been written. Okay, so that could be the thing in the live data. In the live data, errors are there. A lot of errors are there, data errors. So that's what I'm telling
Mm-hmm.
you. Live data in
Mm-hmm.
OLTP databases, when the live data comes in, it's like mail. I mean, most of the data is quite unstructured. It's quite unordered,
Mm-hmm.
right?
Mm-hmm.
So now is the job of a that is the job of a data engineer to make it order, to make it or to order the data in a relevant way. Now,
Yeah.
after that, that is the work. After that, the work of data analysis comes into picture. Data analysts or data
Mm-hmm.
scientists,
Mm-hmm.
they need to use that data. Data engineer prepares the data. He prepares the data. I mean, he does not prepare the data. He just how should I tell you? Okay, let me. If you can see it, can you see the what PPT here? I'll show you right now.
Yeah. Oh, yeah, I can see.
Um, okay, let me help you explain this thing. I hope you can see the white screen.
Yes, I can.
Okay. Let's say if there's a OLTP database. Now,
Okay.
some data is moved to the OLAP, the historical data, which has gone and fixed. But now it's unstructured. Okay,
Okay.
this is unstructured data.
Mm-hmm.
It's quite randomly spread. Randomly spread. Now, that's the work of a data engineer. They will do like this. They will maintain certain databases inside a database. This is the cloud, and a cloud
Mm-hmm.
maintains many types of databases. Now, let's say data engineer says that customers' data should be kept in this database, orders data should be kept in this database, products data should be kept in this database, customer
Mm-hmm.
locations should be kept in this database, and January data is kept in this database. So a cloud, I hope you're getting it, like
Yes, I
February
get it.
data.
I understand. 100%.
Yes. So the work of data engineer is to segregate the data, is to segregate the big unstructured data, big unstructured data into Not structured. I would not say structured, but okay, let's say structured, but not cleaned. Okay, that's not his job to clean the data. He just
Okay.
put he just segregates. He just puts the customer's data in a separate database. He just put a customer location separate database, January data, and he can maintain thousands and thousands of databases inside a cloud. Right now,
Yeah.
it's the job.
Yes.
Now the job of a data analyst is now the job of a data analyst is now a data analyst want to work on a data analyst of want to say, okay, there's one database called sales transactions. Now data analysts want to see like the customer analysis or the transaction analysis of each customer. So he would be needing some customer details, some of the customer details, not all. He would be needed,
Mm-hmm.
like say he would be needed the name of the customer. He would be
Mm-hmm.
needed a place from this customer location, let's say the city of a customer, the state of a customer. He
Mm-hmm.
would be
Come in.
needed the transaction from some data from the transaction database. So I hope you're getting it right. Price of the
100%.
product
Yes.
and how many items he borrowed and what was
Uh-huh.
his total sales, I mean that was not total sales, the total cost.
Yeah.
So now data analyst will be making a database. Now, this
Okay.
database will be created by a data analyst. Now, he will be maintaining this
So,
database.
sorry,
He
just a
will,
quick question. Quick question. So, from the cloud where all the data is in, you're saying that a data analyst sieves out the data, the relevant information, and
relevant, yeah.
creates. Okay, so it creates meaningful data from the cloud. So basically,
Database. Yes.
got it.
Yes.
Got it.
Yeah, go ahead.
No, I'm just trying to make sense of it, which is making sense. So basically, I'm saying that the data analyst takes the information from the cloud that a customer has put in. So, for example, how you made Netflix. So they're putting their information, all their details, date of birth, it's just random information about the customer, about the entity. They've put it into the cloud. So a data analyst sieves out the information from the cloud and makes sense of it. That creates an individual profile based on the pool of information that's been given already.
Yeah.
Got it.
You're right.
Got
And
it.
I really appreciate that you're getting it. It's a
Yes.
little tricky things, and people don't get it so fast, but I really appreciate that you got it. Okay.
Thank you.
So that's a database. Now, this database, data analyst will be storing. Now, data analyst will be storing this database inside a new cloud, or let's say inside this cloud only with a. Okay. Now, this database has been created by a data analyst for data analysis in the future. Okay. Now, in the future, if a
Okay.
data analyst needs this data only with the relevant information, let's say he wants the data for May, so he will be, let's say there is one May data, and he would be needing the month from this data, and let's keep it here month. So now he will be doing a data analysis in the future using this database. Let's say its name is DA1. So he will be using DA1 for a data analysis. Now the thing is, because it's not clean, okay, and while creating the database here, a data analyst is not cleaning the data. Okay? You know that it's a live data, right? It's not a clean
Yes.
data.
Yes.
So now, when the analysis starts, now the first step is to prepare and clean the data, which will be done in Python. Now, this will be done by the data analyst.
So you clean the data first.
You clean the data first. You prepare the data first, and it requires 75% of the time in preparing one project. in preparing one data analysis. So to build one model, it just requires 25% of the time, but to clean the data, to prepare the data for the analysis, it requires 75%. Are you getting it?
Okay. What? Sorry, go back. Say what requires 75%.
Like if you are, okay, let me ask you, if we are working on a project, okay?
Yes.
Now,
Yes.
and a data has been given to you. Now, around 75% of the time will go into data cleaning, data preparation, EDA.
Got it. Got it. I understand.
Yeah. Exploratory data analysis. You can write the full form of EDA. It's necessary.
What does EDA mean?
Exploratory data. It's just a cleaning and preparing of the data.
Okay.
Exploratory data analysis.
Exploratory data analysis.
Yeah. So firstly, the EDA would be done. And after that, it's just like model building in a way.
Hello?
Quick.
Hello?
Hello?
So hold on. I can't hear you. Hold on. Sorry, hold on. I can barely hear you.
Okay.
Hello?
Hello?
Yeah, it went off. I can barely hear you now. Sorry. Hold on.
Can you hear me?
Wait, hold on. Just hold on 1 second. Let me try and check something.
Okay.
Shit. Hold on. Probably I'm in a class. Hello?
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 Can you hear me?
Yeah, I can hear you better now. I can hear you now.
Okay.
I can hear you now. Sorry, you went off for a second. I can hear you now.
Okay.
Hello?
Yeah. Can we continue?
Yeah, we can continue. Yes.
Okay. Okay. So I hope you understand the works, the job of a data engineer and a data analyst.
Yes.
Okay. Now, let's move on to the worthwhile.
Sorry, quick one. So can you go back for once? I have a quick question.
Yeah.
Go back for a second. So the data analyst, I got that part in terms of sifting out the information. So basically in the cloud, there's a lot of data. The data analyst studies it and kind of makes meaning. So basically filter, it's like a filter. Basically takes the filter out for and based on an individual customer and makes sense of the data basically. But you said and what you did, what did you mention regarding the engineer? What does the engineer do? I know the analyst. The analyst, you've broken it down very well, but what does the engineer do?
Engineer segregates the big unstructured data into structured data.
Okay, so you said the engineer separates the big structured data,
Yeah,
and
like it's a like I said that in OLAP it's randomly spread. The data is randomly spread. Now it's
okay,
a work of, and it's really a hard work. It's a hard work
mm-hmm.
because it requires a lot of patience. It requires each and everything because a data engineer has to work with a lot of data. He needs to segregate some customer data, and he keeps a customer data in a separate customer database that he look down to filter out locations and put it in the customer locations data. So like that.
Yes.
Yeah. For
So
data
that's that
analyst,
engineer. Okay.
yeah. Data analyst is only needs the relevant features, relevant info.
So okay, this is hold on. Relevant info, and so for the data analyst, it looks for relevant info, and for the engineer, it looks for what? Segregation.
All the data. He looks for all the data. He never misses out. He can never miss out on a single detail as well. He needs to look out each and every data point, and he needs to segregate. He need to make groups. He need to make different data bases for different things like customer details in one database, all the details in another database. So let's say, okay, let me give you another example. Like it's
Mm-hmm.
let's say from an OLAP, if the data engineer has made one database, okay,
Mm-hmm.
and it's a
Mm-hmm.
database of customers information. So the customer
Okay.
information could be like customer name, age, his date of birth, like his ID, his profession, and whatnot, his city, and how many transactions he has done, his order ID 1, order ID 2, order ID
Yeah.
3, like this one. So there can be
Yeah.
thousands of information of the customer. But a data
Yeah.
analyst now would be needing only data analyst like me. I would be needing only the customer name and the customer ID from this data. Okay, I will
Oh,
be filtering
okay.
out customer name and customer ID from this data. And let's say in a transactional data, I need the price of the item, I need the quantity which I mean the
Yes.
quantity that the customer name has ordered.
Yes.
Are you getting it? Only the relevant
Yes.
data,
Yes.
only the relevant data, not the complete data, not the complete
Ye-
customer's data. Data analyst would be needed, right?
Yes.
Like just two features. Like data analyst
Yeah.
needed just two features from this hundreds of features which data
Got
engineer
it.
has.
Got it. Got it.
Because our data analysis should be compact and it should not be on the complete data because in the complete data there are always some irrelevant features. So we need to get rid
Correct.
of those irrelevant features and we need to focus on only the relevant information to
Yes.
do the best um, databases more effective, having the more accuracy, having the predictions more closer to the reality. Are you
Yeah.
getting it?
Yes.
That's the thing.
Got it. So the information that is not relevant, what happens to it? It just stays in the cloud?
Yeah, it stays in the cloud. It stays in the cloud.
Okay.
Like
And
the cloud
it's
migration.
not used by anything. Like it just stays there. It's just not used on like so it's basically useless. It just sits there.
Yeah, let's say after December, let's say after 6 months in December, the company would be needing an analysis of the customers who are above 30 years of age, and the customers and the company has decided to give some um, what we call discount offers to
Mm-hmm.
those customers, discount offers
Yeah.
to those customers. So now they would be needing age, customer name, ID, city, and many more things from other databases, right?
Yes.
So all these informations, relevant informations, are irrelevant for some kind of data analysis, but
Mm-hmm.
it depends on the business problem. It depends on the business problem, right? So in this
Yeah.
business problem, we would be needing the age, right?
Mm-hmm.
Okay. In this business problem, with let's say in this business problem one, we does not need the age much. So why would
Yes.
we need age in this one, right? So it's irrelevant in this one. All the irrelevant features will be remaining the same. And
Mm-hmm.
it's a cloud. Cloud contains the details, and it
Yes.
can be used in the future.
In the
It's a
future,
store.
okay. When you need it is when it's now referred to.
Yes, whatever the business
Okay.
problem asks us to do. It depends on the
Okay, got it.
business.
Makes sense. Makes sense.
Yes, sir. Okay, so now we should move on to the next thing.
Sure.
Anything else you want to ask?
No, that's all. I got it.
Okay, now this data analysis is being done on Python language, which is the most demandable language nowadays.
So data analysis is done on Python language. Is that what you said?
It can be done in many languages like R or Go language. but Python is the most usable and most demandable language because of its features, right? We will be going through the features of Python in the later half of the session. Okay,
Okay.
why
Okay.
the, why Python? Why people are considering Python for data analysis?
Okay.
Okay, let me show you one data. Can you see it? It's a sample data of Amazon. So
Okay.
just look at
Okay. I
just
see
look
some.
at
I see
data.
data shipping. I see your data. What data is this? What category of data is this?
It's a orders data. It's a Amazon orders data. It's a sample data of
Okay.
Amazon for
Got
United
it.
States.
Got it.
It's a order ID, order date, shipping date, ship mode, customer ID, customer name, segment.
Mm-hmm.
Okay, now I
Mm-hmm.
will be telling you some things about the data. I will be asking you certain questions on this data point. So now,
Okay.
first of all, data. What is data? You told me data is information. Okay. For
Mm-hmm.
data science, data is of two types. Okay, there are two types of data. In a structured, in a structured data, which a data analyst has been doing.
Mm-hmm.
Now, one type of data is continuous. The other type of data is categorical. What do you understand by continuous or categorical data? Just by looking at the name.
Okay. So
Mhm.
categorical data. When you say category, okay, so I'm looking at categories like data that's based on different now different maybe okay, let's pick like for example movies. So when you talk about categorical, so categorical could be maybe different types of movies like drama, action, thriller, comedy. This is why I'm looking at it, But continuous is like maybe information on maybe one of those categories, but is information that keeps changing in terms of like how many people subscribe to one of those categories. That's how I think of it. I don't know if I'm correct.
For the categorical data, you're 100% correct. It's a category.
Okay.
It's a class. It's a class. It's like a class, right? The
Okay.
genre,
Yes.
genre you were telling about the movies, the comedy, the
Yes.
sci-fi, or anything, right? So
Yes.
that would be a category. Okay. Continuous data is the numerical,
Okay.
on which the mathematical operations can be
So it's numerical.
done. It's a numerical data on which the mathematical operations can be done. Like we can find the average of that thing. We can find the sum of those things. We can find the standard deviation of the data from the mean and anything. We will be doing all these things in data science basics and statistical analysis.
Yeah.
No need to worry about that. But I'm just talking about the data right now. Okay, so that's a continuous data is a data which is numerical, on which mathematical operations can be done, and no grouping can be done on this data. Okay, no
Yeah.
grouping can be done. Okay, I'll shortly. I'll tell you. I will explain you shortly what grouping means. Okay, now categorical data is a category is a class data. No
Yes.
mathematical operations can be done on it, right? No
Yeah.
mathematical operations can be done on it, but grouping can be done.
What can be done?
Grouping can be
Group it.
done.
Okay.
Now, look at the data. What do you think? Okay, just tell me the features. These are the features: ship date, ship mode, customer ID. These are features of the data. Features means the information. What information do you think? Which kind of data do you think is a continuous data in this data set?
Um.
Continuous.
Continuous. Okay. Continuous. Um. Continuous is maybe. Let me look at this. So just give me a second. I think so. Numerical. Which So hold on. Numerical would be date of birth, which can be mathematically that can be done. Okay,
No future.
maybe order number,
Order ID.
order ID. Sorry.
Okay, okay. So can we like get a sum of all these order IDs? Like, will that be a good information to get the sum of all this, to get the average of all this?
Yeah. So for example, so an order ID, maybe to know the frequency a specific product is bought. So that's why you know like the best sellers of a specific item. So that's good information. So you know what is trending or what is in demand versus what is not in demand.
Sorry, I didn't get it. Your voice was breaking.
So
Can you repeat
okay,
it?
so that's why I said the order ID. Why the order ID is important. So when you say the order, okay, wait, okay, the order ID, I said basically, if a certain customer or certain people are buying a certain item, they can know the difference between what is in demand and what is not in demand.
Mhm. Okay.
I don't know if that
Uh,
makes sense.
order ID, order ID. That's more of a qualitative thing. That's more of a qualitative thing. For a data analyst, it's more important to work on the quantitative aspect of the things. Like that's
Quantitative. Oh,
uh,
okay.
quantitative, the values aspect of the thing. The way that you're thinking like a manager. You're thinking like
Okay.
you're thinking like um, the chairman, right? That
Yes.
uh, you're just focusing on the qualitative aspect, like you are going in depth of that. Like if a order ID is this, if because order ID, let's say if a person's order ID is this, then think that which kind of product is he buying, or which kind of product is he
Yes.
focusing on, and
Correct.
making a comparison of that. So that's more qualitative. We can move it in this way. I mean, we can move it in the same direction using the quantitative things, but that's more of a complex things. Okay. Now I'm just asking, like, does this order ID uh, is this order ID a continuous thing? Can we get a sum of it? Can we add them, and can their additional value can give us certain
Oh,
importance? Like, is that important?
okay. I get what you mean. No, you can't add it.
Yes, we cannot add it.
Okay, I understand. I understand. But in regards to so I can't see yours. So let me see what you can you add. Can I see your list again of column? Let me see the list again. Let me see what you can add. I understand what you're saying now.
I'm showing you.
Okay. But you can add profit. This is profit. This is no.
So all
Okay.
the continuous columns.
Yes, correct.
Yes, that's what I was telling you. So
Yeah.
continuous columns are the numerical data on which mathematical operations can be. Mathematical operations can be sum, averages, mean, median, standard deviation, covariance,
Yeah.
correlation, which we will be doing in the statistical analysis of data. And so I hope you're getting it, right?
Yes, I am.
So these are the numerical data. And all the others are, what do you think about these things? What do you think?
So basically what you're saying is that okay, so sorry, hold on. Continuous wait.
Okay, let me show
Which
you the
can be,
notes.
so continuous is everything that can be mathematical, like the price, profits, quantity, anything that can be valued in terms of calculated. But categoric is more of the, in terms of like the specifics of the type of like as we mentioned, like the type of how would I put it down in English now? So okay, I
Classes.
understand what you're saying now. Sorry, say that again.
The classes, the
The classes,
classifications.
yes, yes, classification, yes.
Yes,
Okay,
like
I get it now.
class of comedy films, action films,
Yes,
thrillers,
yes,
suspense.
Yes.
those classes.
Yes. I
Grouping
get
can be
it.
done on them. Like
I
if we
get it
group,
now.
if we group the suspense films all like that.
Yes, I get it now. I get it 100%. So I understand now. So
Yes.
continuous is more of
Let's
numerical.
say there are
Anything that can be done calculated.
many movies, the suspense. Okay, let me ask you a question. Let's say, okay, let me ask you. I think we are talking more on movies. I think you are really interested in movies. Okay.
Because you mentioned Netflix, so that was like a good platform to understand. I use Netflix, so it's a good platform for me to understand. I don't know if you understand what I'm saying.
Okay. What's your favorite genre?
So my favorite genre is horror, for example.
Oh, that's my favorite too. That's why I've written second. Okay.
All right.
Right. That's a movie name. Let's say movie name. I'm not writing a movie name, right? I'm
Sure.
just writing.
Genres or categories.
It's just a simple quiz. And the number of viewers of these films and the movie names. So 1,000 viewers have watched this, 2,000 viewers have watched this, 1,500 viewers have watched this, 1,500 viewers have watched this movie, and 2,000 viewers have watched this, 1,000 viewers have watched this, 1,500, and let's say 500. Now, I've given you a data of this, and the company wants to have let's say, comparison analysis. Okay.
Mm-hmm.
Now, if you are a
Mm-hmm.
data analyst, think like a data analyst. You want to do a comparison analysis between the movies, between the genres.
Mm-hmm.
Okay. You want to tell me which one will be the categorical data and which one will be the continuous data in this data?
So continuous will be the views because the views will continue to change, and it's a number. It's a number, so it can be calculated on.
Exactly, sir. You're 100% correct. Now the thing is, I'm wondering which genre recommended, which genre is preferred by most of the people, preferred or watched by
Okay.
most of the people, like the maximum number of times. So how would you do it? Like, I just want to ask you, which genre has got the maximum watch? I'm asking about the genre, not the movie.
Sure. Sure. So the maximum watch, you need to use the views to tell that. So you look at the horror and so I can't see what is underneath comedy. I can't read what that is. I think it's horror and yeah, it's horror. Yes. The horror
Yeah.
has the most views based on the number, which is a
2000.
continuous number. So use yes, 2000. Yeah.
Okay. Are you sure?
Absolutely.
Okay. I'm not asking about the movie name, sir. I'm asking about the genre. Just think of it like an analyst. I'm asking which genre is watched by most of the people. Movie names could be different. M1, M2, and
Yes. Yes. So the genre is horror.
horror. Okay.
Yes.
I'll show you one thing again. Like you were asking me about this grouping.
Yes.
Grouping can be done on the categorical data, and genre is a categorical data. Yes, it's not a continuous
Correct.
data.
Correct.
Grouping can be done on the data. Why the grouping is needed? Why the grouping is needed? Why people need grouping? Why data analysts need grouping? Why they need to segregate data? to do the analysis. So now the thing is, see, you have given me an answer, 2000. The horror is watched by maximum number of people. See,
Yes.
horror is here as well. Horror is here as well. Horror is here as well. Now the people who are watching horror genre are 1000 plus 2000, 3000 plus 5000. So the grouping is done on the categorical data, and mathematical operations are done on the continuous data. Now, I can say that 5,000 people have watched the horror genre. How many people have watched comedy genre? 1,000 here? 1,500?
1,000. It is. There's 1,500 and not 1,000.
3,000. Right?
Yes.
Action.
That's 1,500. That's 2,000. Yes.
Sci-fi.
That's 1,000. Yes.
But let's say, if the comedy here is 20, let's say, if this comedy is like Mr. Bean's comedy, and if it gets something or something like what's that movie name? I'm getting it. Rowan Atkinson was the hero, and
Which one?
I'm not getting the name of the movie. But
Was it? What category is he under?
that was, I think, comedy. It was actual thriller comedy. Rowan Atkinson was the detective, and it was comical detective.
Okay. I think I know it.
So let's say comedy here has 4,500. So now that 1,000, 7,000. So we can say the comedy has the highest viewership. Are you getting it?
Yes.
So we have done the analysis after grouping the data, after grouping the categories. So now we can say the comedy has the highest viewership.
Yes.
We don't have to look independently. We don't have to look at the numbers independently. We have to do the grouping on the genre to look at the analysis.
Yes.
Otherwise, it will be wrong. Are you getting my
Yes.
point?
You have to. You have to group them so it's easier for you to collate.
Yes. Are you getting it?
Yes, I am.
So that's a difference. That's a difference. That's now how you have to think about the data. Okay.
Got it. So group the data, then collate your information. Oh, got it.
Yes. Let's say if I show you this data again, and if I ask you like region, so here is the region data. Now, if I ask you to do a comparison analysis between the profit comparison analysis, here's the profit, and a comparison analysis of profit between West and the South. Right? So how would you do it?
I'll first group all the West to see how many are the West, then group to see how much are from the South.
And then group the categorical data is region. We group it, and we get the sum of the profit in each grouping, and then we can do the profit analysis, right?
Got it. Yes, I understand. Yes, correct. So you sort out by the region. So you group, for example, the South first, then, as you said, check numerically how much profit or money, how much profit was made from those regions. Then based on each region, you understand? So you check the region first, calculate the numerical value from each region, then compare versus each one another.
Yes, compare like which region was getting the highest profit. Right?
Correct.
And we the difference between the profit.
Yes.
Right.
Yes, correct.
Exactly. I hope you got it. And
I am getting it now.
I really appreciate that you're explaining your answer. A few more people do this. I really appreciate that. Okay.
No problem.
Now, here's a catch. Here's a different thing coming on. And now you need to be really focused. There are two types of
Okay.
categorical data. There are two types of categorical data. Just by movies and genres, I think I can feel a connect with you. I just want to just on a light things. I just want to
Mhm.
ask you, like, what movies are you watching? I mean, you must be watching seasons as well, right?
Okay, let me see. The last one I was watching was, for example, the last one I was watching was Stranger Things, which
Oh,
is uh, Stranger Things, which is almost sci-fi. It's a sci-fi movie on Netflix, for example.
is it sci-fi? It's not horror.
It's in between. It's actually horror. Sorry, you're right. It's horror. It's more of horror. It's in between both, but horror. You're right. It's actually horror. You're right.
Yeah, I haven't watched it, but last I watched on Netflix was Money Heist. I hope you have heard it about. Heard
Yeah, I know
about.
of it. I know of Money Heist. Yes, I haven't watched it, but I know of it.
Yeah. So I'm a big fan of Avengers and everything like that. I was. Yeah.
All right.
Okay. There are two types of categorical data: nominal categorical data,
Nominal.
categorical data, and the other one is ordinal categorical data.
Nominal, categorical, and ordinal.
Ordinal, yeah. Data which when the data if we order this kind of data, if we order this kind of data, it makes our data analysis easier. It makes our data analysis easier by grouping and aggregations, by grouping and aggregations. Right.
Yeah.
Aggregations are mathematical operations. Okay. Okay.
Yeah.
Aggregations are the mathematical operations. Grouping is done on get. You need to be focused, and you need to learn one thing from this session today. Grouping is done on the categorical data, and aggregations are done on the continuous data. Right? Like the example which I told you here. We did the grouping on the genre, and we did the
Yes.
aggregation on the viewers. Right.
Yes. Yes.
Aggregation can be anything. Some aggregation is a name for mathematical operations. So I've written mathematical
Okay. Let me
operations.
let me make note of that. So, say what you just said again. I have to make. Wait, hold on. I have to make a. This is a very important note you just mentioned. Hold on 1 second.
That's really important. That's really important as per
So
the
one
data
second.
analysis is concerned.
So continue. So can you repeat what you said something right now, the way you mentioned it? I want to take a note of it. So it's a continuous data. Okay, that's why you have a numerical data on mathematical operations done. Categorical
Okay, right. Grouping is done on categorical data.
grouping
Grouping
because
is done,
categorical
yeah, and
categorical
aggregations
data aggregation aggregation is
is,
what?
is done on continuous data.
Continuous data. Got it.
Here. Now, ordinal categorical data, if we order this kind of data, it makes our data analysis easier and makes sense. It makes sense. It gives a meaning to the data. It gives a meaning to the data. But in case of a nominal categorical data, it does not give any meaning. Like it does not make much sense. It does not make much sense, even if it's ordered or unordered, right?
Yeah. Yeah.
It does not make much sense to just read
So,
it. And
so
I mean, I don't want you to read it. I just want you to understand it, and I just want you to explain it in your words.
okay. So nominal. It doesn't make sense even if it's order or unordered. Ordinal. If we order this kind of data, it makes our data analysis easier by grouping mathematically, and it gives a meaning of the data. Okay. I don't understand what it is. I think we need to go deeper so I can get what it means. So nominal, it doesn't make any sense. So what do you mean by it doesn't make sense? Is it I'm trying to make meaning of it.
Okay. Okay. Okay.
So tired.
That's a movie. That's a movie name. Let's consider
Sorry,
a
sorry.
stranger.
Give me 2 minutes. Sorry, please give me 2 minutes. Hold on. Give me 2 minutes. Hold on, please. Bestie. Um, I will sit up to my tree. Go to the tree for my room. Just take this away. Close the door. Thank you. Don't close the door. Sorry, I'm back. Sorry about that.
It's okay. It's okay.
Sorry.
Can you tell me another horror movie? I was thinking of scary movie. Okay. Um, online course. 200,000. 300,000. Okay. Now, what do you think about movie ID? If I order this, like if I order this, order means like if some numbers are given like this,
Mm-hmm.
43, 9, 7. If I can order it in ascending order, it will be like this. If I
Mm-hmm.
order it descending order, it will be like this. So is it make like this? If for movie name, if I order it will be ordered by alphabetically, like A comes first, and then E comes, and then S comes. For general
Mm-hmm.
genre, if it gets ordered like this. So the thing is, like if I order movie ID, will it makes the data analysis easier, or will that be helpful? What do you think? Like if I
Okay,
order
I see what you're saying.
will that
Yeah,
make
if you
any
order
sense?
it, yeah, you're making sense. Yes. So if you're getting a bunch of information like this, um, I think let me see. The best way to order that will make more sense for the analyst would be um okay. I would order based on online viewers under the numerical.
Okay,
Is that
okay.
what you is that what you're asking?
Uh, Here we are just concerned with the categorical data.
Okay, just on category. Okay, okay,
So online viewers is a continuous data. So we have
sure.
only three categorical data here, here, and here. So okay, let's forget about movie ID. Let's talk about genre. If we ordered
Okay.
the genre, will that be helpful in data analysis? Will that makes our data analysis easy? Like
If
if
we
we
order
match,
based on genre, yes. If you base on genre, yes, it would.
yes, yes, yes. See, order. Why we order things? Why we order things? Like if we order it, then just look at it carefully. If we order it, then action comes together, horror comes together, and it would be easier for us to group them together. Are you getting it?
Yes.
What about the movie name? Will that be if we order it, will that be giving any like meaning to the data? Will that be
Mm,
providing data analysis?
yeah, if you order it with the category, yeah, I'm thinking yes, it would.
Can we group it? Can we group it? Just think
Yeah, you
as a
can group
group.
uh, you can't group movies. You can group the genres, but you can't group the movies because the movies are independent.
Yes, we cannot group the movie names, right?
Yeah. Yes.
We cannot group the movie names. We cannot. It does not make any sense to order them and then group them because all the movie
Yeah.
names are different. All the movie names are
Yes.
different. All the movie
Yes.
IDs are different. So it's not. It does not make any sense to order them and then group them. Okay. So
Yeah.
only this. This is the ordinal categorical data. Are you getting it? What is the ordinal categorical data? A data, if we order that data, then it would be easier for a data analyst to group it and to do data analysis. And it gives a meaning to to the data
Okay.
analysis. But a
Okay.
nominal categorical data is the data which if we even order it, it does not make any sense. Like it does makes least sense, right? It does not help a
Yeah.
data analyst to solve any problem, like to group it, because this is unique. This is unique
Yes.
for each movie. This is unique
Yes.
IDs for each movie. There are unique names for each movie. Now let's move to the okay. I hope you understand that.
Very well.
Okay, I appreciate that. Now move on to the next data, and I want you to ask which of them is a nominal data and which of them is a categorical data. Can you name some nominal data? Okay, let me ask you this way. What about the shift mode? What about the shift mode?
Let me see. Shift or sorry,
Shift mode.
shift mode. Shift
Yeah.
mode is it looks nominal to me.
Nominal.
Yes.
Okay, I've already put a filter on it.
Okay. I've seen the options. So okay, there's first. Okay, sorry. Go back again. There's first, I saw different options. So ship mode. Okay, it can be grouped. I can see that there are different options there. So it's ordinal because I think when you clicked on the tab, I saw different options.
Yes, it can be
Okay,
grouped.
first,
It
past,
can be
second.
grouped.
Yes, yes, it can be
What
grouped.
about
Yes,
okay? What about the customer ID?
customer ID is unique. Is nominal.
Exactly. What about the customer name?
Which one? Customer name is nominal because it's
Exactly.
unique.
Exactly. And country?
Country is
Oh,
ordinal because it can be grouped.
exactly. I am I really want to appreciate that you got it in once. Um, category?
Category should be category be ordinal because it can be grouped.
Exactly. Product ID.
Product ID would be that's a good one. Product ID, because it will be grouped. It's ordinal because they're different products that are the same, I believe. So it will be ordinal because it can be grouped.
Uh, okay.
No, no, no,
Okay.
no, no,
Okay.
no. Sorry, sorry. It will be nominal. Sorry, it will be nominal because the ID is the product that would be grouped, but the product ID will be nominal because it's unique. Every item has its own specific
ID.
product ID. Yes,
Yes. Yes. Yes.
yes, I get it.
Now I.
Yes,
Now you're getting it. Now you're getting it.
yes,
Okay.
yes.
Okay. Miss. Okay, Sam. Like, let's take a break. Yeah. Let's start. Let's begin. Let's continue. Okay. So I told you much about the science basics. Okay. So what actually is machine learning? Okay. Let me give you one example. Can you hear me?
Very well.
Okay. Let me give you one example then. Okay. So there's one banking sector. There's one banking sector which issues loans, which issues loans for education purposes. Okay. I hope you're getting a business problem. So there is one banking sector which issues loans for education purposes. And okay, there are three processes to be done. Process one, the candidate comes to the bank asks for his information.
So that's KYC.
What?
KYC. That's what we call in banking. You know, so it's KYC. Know your customer.
Yes. Yes. Exactly. Now, the second
Yes.
step is,
Exactly. Yeah.
what can be the second step? Okay,
So this
tell
is
you,
where
let me tell you
okay,
the
this is what
first
I'm thinking. So once
issue the loan or does not issue the loan. This is the third step. What is the second process? What do you think? What could be the second process? Process three is the decision making.
from the
Whether
KYC.
whether the bank wants to issue the loan. Yeah, yeah. Yes. Yes.
So so the second process is so knowing the customer. Sorry.
Yeah, you can tell me. You can tell me.
So,
Hello, can you hear me?
no. Yeah. So this is where we give yeah, I can hear you now. This is where we give the customers the bank's information in terms of our own requirements to access the loan. Because the first stage is knowing the customer, then we
Sorry, your voice is breaking. I think. Okay, let me check it from my side. You can check it too from your side as well. Actually, your voice is breaking. I'm not able to hear you clearly. Can you hear me? Hello? 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 Hello, can you hear me?
sorry, hello, it went off. Can you hear me?
Your
I'm going to
voice is
connect from my
breaking,
phone.
actually.
I was using my phone before. I'm going to go back to my phone. Yeah, let me go back to my phone.
Okay.
So I can reconnect to my phone.
Okay.
It was better on my phone.
Okay, okay. Okay, okay.
Wait, hold on. Okay. What doesn't V. Kivich. Oh my goodness, this is rubbish. Is this? Sorry, hold on. What's this thing called? Okay, hold on a second. Can you hear me?
Yes, I can hear you. Can you hear me?
Yeah, I want to go back to my phone because I think the network on my I don't know it was better on my phone, so it doesn't keep on cutting off.
Okay. Now can you hear me?
Yeah, I can hear you.
Okay, let's move ahead now. Okay.
Okay.
About,
Where's the I can't see your sheet anymore.
You're not able
Here
to
we
see
go.
the sheet. Okay, let me present it again.
Yeah, I can see it. Okay.
Can you see it now?
Yeah, I can see it. Yes.
Okay, very well. Then, okay. I was asking you what could be the process too, and I think I heard you that you were saying knowing the customer, right?
Yes.
Yes. So that's the customer
No, no.
verification.
So I was saying that no. Yeah, exactly customer verification. Yeah. So what I was saying is that since the first process is knowing the customer, gets their information, they need to know the bank's information too in terms of the requirements needed to access the loan. That's what I thought.
Yeah, but like if a customer is reaching out to a bank, then he must have searched for the banks, like if they are giving a loan for the education purpose. And let's suppose it's a banking sector, it's a bank which is very famous, dependable in a country, in a state. Okay.
Mhm.
Okay. So now that's the customer detail verification. Let's say if it's a manual verification, if it's a manual verification, then it's a loss. 10 to 15 days. It will take 10 to 15 days for a manual verification. Like a person will verify the details of each and every detail of the customer, and then he reaches on to the next process, and there the decision making is done. Like if the details matches with certain criteria, then the loan is issued. Otherwise, the loan will not be issued to the person. Okay. So the manual verification is taking 10 to 15 days, which is too much of the days, too much of the days. So it's wasting. It's actually wasting. It's actually wasting the customer's time. It's actually wasting the time of customers as well as the time of the bank. Okay. Because the bank
Yeah.
needs to do the decision making in a very quick time. They need to, what should I say? They need to look at the customers. They need to issue the loans for making profits in the future. So that's the thing. But now, let's say if we have a data, okay. Now we have the customers' data. Here we get the customers' data, or I will say information, because data is the information. Now, if we put a machine or a machine learning, not a machine, if we put a model, for customer details verification, machine learning model is like if we are teaching our machine, if we are teaching our machine to get the inputs, and then give out the output. Are you getting it?
Say that one more time. Say that one more time.
Okay. So now the manual verification was taking 10 to 15 days. So it's wasting
Okay.
the customer's time as well as the bank's time. Now the bank has decided to make a machine learning model for the process 2, in which the model will be getting the information of the customers as an inputs, and by looking at those inputs quickly and going through all the inputs, it will give out an output. The output will be in the form of, the output can be in the form of, there can be two outputs, no and yes.
Okay.
If the details matches with the, if the inputs, what are the inputs?
The inputs would be like the customer information. Isn't that inputs?
Yes,
Like the
exactly.
come in. Sorry, what's that?
Yes.
Yes, allow. Okay.
Okay. So the inputs would be the customer information, and it will be going through that customer's information. It's a model because it's a machine learning model. It will be faster and it will be more accurate. It will be more effective, and it will be giving out the output in the form of yes or no quickly. And it will take, let's say, it will take a 1 day time to decide. Like we take the customer information on set.
Okay. Okay. So basically, it reduces the time from 15.
And
So
yeah.
So it reduces the time from 15 days when it was manual now to 1 day, based on the machine learning inputs that's automatically taken out to just make the whole process of registration and verification faster, right? Is that what you're saying?
Yes, exactly.
Okay. All right. Got
Are you
it.
getting it? Are you getting it?
Yes, I do. Yes.
Okay. If you want, you can take a screenshot of this.
Yes, I will do that now. Hold on. Let me do that.
Yeah. You can take the screenshots
Done.
of all the
So KYC.
PPTs. Have you taken it?
Yes. So hold on. I'm just making my notes now. Process 2. Can you go back one second? Process 2 was. Can you go back again? 1 second. KYC. Process 2 was customer details. Customer details verification. And number 3, process 3 is what's this? Issue loan. Okay. Issue loan. Issue loan to customer. Okay, so the machine learning comes in the middle in process 2, right?
Yeah.
Okay. Learning to make process faster. Got it. All right.
Okay. So yeah, it will be making the process of issuing loans and checking whether a customer is good or bad. Yes.
Yes. Yes. Correct.
It's a, let's say it's a bad customer. It's a good customer. So the output will be in this form. Okay. Let me give you one data. Let's say we get a bank asks you, you are a machine learning modeler. A bank gave you a data. Of, let's say, January to 2022 to October 2022. Okay.
Yeah.
Let's say the bank gave you a data of 2022.
Okay.
From January to December, the complete year. Now, what's the work of a modeler? First of all, there will be a data. Okay, there will be some features, and there are features, like there are certain features. Let's say the customer ID, the customer name, his age, his income, his city from where he came from, his state, the number of credit cards he owned, number of credit cards, credit lines, number of credit lines, and what else can be? What else can be? Percent rate,
Um,
interest rate, percent. Okay. Now there will be. I'm not able to write because my screen is small,
it's
but
fine.
there can be many information, and then there will be a final output information. Now that's an output information. Status. Let's say status. It's a good customer. It's a good customer. It's a good customer. It's a bad customer. Good,
Okay. So
bad.
that's like the last column. That's like the total, like basically giving the final verdict if he's a good or bad customer after all the inputs put in.
Yes, yes.
Yeah.
Like it's an earlier model. It's a previous model.
Yeah.
It's a previous model, and on this data, the model has predicted. On this data, the model has predicted the good, bad customers according as per the information. Right now,
Yeah.
you are the new model. You are the new modeler. You are the new machine learning modeler. They will be giving you the previous model. They will be giving you the previous year data. Let's say 2022, and they will be asking you to predict. They will be asking you to predict to make, first of all, to make a new model. To make a new model, you will be making a new model on the data, on this data, because the previous model, this data has been predicted by the previous modeler. This data has been predicted by the previous modeler, and this data has been predicted on the previous data. There must be some previous data. Let's say 2021 data, right?
Mm-hmm.
And this is a data 2022 data. Now you are a new modeler. Now the company, the bank wants you to predict the output, the status. The output is our status. To predict the output for, let's say, January 2023 to March 2023. Are you getting it?
Yes.
Are you getting it?
Yes, I am.
So can you explain, like, what's the question, like what we're doing, so that I can understand, like,
So
if you're getting it or
sure. So basically,
yeah.
you created a model like a customer applying to the bank, his information, date, city where he lives, basically like a KYC at the end, based on in terms of his previous record, in terms of where he banks credit cards, and the bank will basically give a verdict if he's a bankable customer or non-bankable customer. Then you are creating a new model to basically um, predict the second part is to predict the output. I'm just trying to understand what you're trying to mean here because the January 2023 to March, I'm trying to still understand what you're trying to go to. I don't quite understand that part yet. But the table, I got that part in terms of the previous model as like history of a customer and his inputs. But within the new model, I don't quite understand what you're trying to say yet. I'm still trying to understand where you're going.
Okay, I
Hello?
was saying, I was saying that. Can you hear me?
Yeah, I can hear you very well. Yes.
I was saying that the company has given you. You are the new modeler, and you joined the organization on, let's say, January 2023. Okay. Now
Okay.
the
Okay.
company gave you. Now the company has given you the data of 2022, and this is the data of
Yes.
2020.
Okay, I get it now. Okay. The
Okay.
past data. Okay. Yes.
Yeah, the past data. Obviously, like the data analysis or the models are made on the historical data. Yeah. Okay.
Correct.
Now the thing is, what is the work of a data modeler? See, we always first thing is that we have to separate, or we have to split the data into the training data set and the testing data set. The training data set and the testing data set. Please write it. I want you to write it, and
Okay.
then I will explain.
Sure.
This is
So
the first
so
step.
separate into the data, into the training data set. Okay. So this is, so what will we put this heading as? I'm trying to think of what we'll put this heading as. Hold on. This is,
You can put it like, okay, just put, we have to, okay, this is the business problem. We have to predict the output. We have to predict the status, or the, what was the word that you told? That word was really apt. What was the word that
KYC?
you used for, I don't know. That
Is it
for the column, for the output column.
Is it KYC? Like, knowing is it, okay, bankable or non-bankable?
Yes, bankable or not bankable. That was a very apt
Okay.
thing. Okay.
Yes.
To predict the status of the customers, if it's bankable or not bankable, for January 2023 to March 2023.
Yes. Okay, got it. So Jan 2023 to March 2023. Okay. Then you said the two, so there's a training data sheet.
We have to split the data into a training data set and a testing data set.
Training data set and testing data set.
Okay.
So split.
Now,
Separate into two. Separate into two. Okay, got it. I'm on. Let's go.
we have to split the complete data set. The company has provided you the data set for you to do, and they have asked you to make the model on this data set, whichever 2022. And now, whatever model you will be building on this data set, you need to check your model if it's working or not on the new data sets, like on the new values, right?
Yeah.
Are you getting it?
Yeah.
Okay.
Yes.
Now, for evaluation, let's say you have why we are splitting our data. Why we are splitting our data? That's the question. You know why we are splitting our data? Let's say if we have made a model on this data, let's say if we have made a model on this complete data, and we are checking on the new data set, we are checking on 2023 data, 2023 Jan to March data, then it would be like, it would be a waste of time. Like it would be a waste of time. It would give, we will not get time to check. We will not get time to check our model. Are you getting it? See,
sorry, say that again. So what it's checking. So you said checking on 2023 to March 2023. Why was it? Sorry, maybe I missed something. Why is it a waste of time?
Okay, let me tell you again. See, let's say.
Sorry.
Okay, let's say situation. It's just a hypothetical situation.
Mm-hmm.
Let's say if we have not.
Sure.
Okay, the question is why we are splitting. Okay, let's say we are not splitting the data. Let's say we are using the complete data, the 2022 data, and we are making a model on this data. And then we are checking or testing our model. And if we are checking or testing our model on the data on which we have to predict, right? So testing our model testing our model on that data, uh, on which we have to predict. And if it says your model's accuracy on this testing data, and if it says your model's accuracy on this new data is 55%. And here, when we made the model, when we made the model on the complete data, your accuracy was 90%. Right? Let's say your accuracy was 90%. And then if we check our data on the data on which we have to predict the bankable and unbankable, if it says your model accuracy is not new data, it will be a waste of time. We have to again make a model on it. Are you getting it? We have to again do some changes. So that's why you have to listen this very carefully. So that's why we have to split our data, like we have to split our 2022 data from, let's say, January to October, and then October to December. We have to make the model on this training data, and then we have to test our model on this data. Are you getting it? And then after testing this data around 2 to 3 times, and if we get a model accuracy, let's say training, this is our training data set. This is our training data set. And if we get accuracy of 85% on our training data set, and this is our testing data set on which we test our model, and it gives us an accuracy of, let's say, 75%, then we can make some changes here only. We can make some changes here only. And after that, we've made some changes. We have improved our model. Let's say after making some changes, after improving, it becomes the testing data set. The testing data set accuracy becomes, let's say, 78%, and that's the maximum. Then we can test. Then we can put the new data on it. So that will not be a waste of time. Okay, that's why we are splitting. And on the splitted data, we are making a model on the training data. Model is made on the training data. Model is always built on the training data set, and model is always tested or evaluated on the testing data set. Right. And then after that, we put, after checking all the accuracies, after getting all the improved accuracies, then we put the new data of 2023, Jan to March. We cannot put directly, we cannot make the entire model on the complete data and then check our model on the data which we need to, which we need the results. We cannot directly go on those data. We have to check our data here only, in these data only. Points.
Okay.
Are you getting it?
Yes.
Okay. So, can you tell me, like, just can you explain so that I can make sure that you understood it?
So,
otherwise I will have to explain.
So I'm sorry, you're right. Because I have a few questions, to be quite honest. I'm a little lost, but I'm a little lost. So this is where I'm lost from. So I know when we created the table, you said, excuse me, split the data into training data for testing data. So once you created the table, we have the bankable and unbankable. You understand? So I remember that. Yes. When you said 90%, so basically you're saying the 90% is based on the bankable customers. Is that what you're trying to say?
No. Okay.
That's what I'm lost, because the 90% that you put here, for example,
so the 90% you put here on this model here that we put, like the bankable and unbankable, on the data for 2022 for January. Okay, I'm quite lost. I'm sorry. I'm quite confused on this part. I'm very confused.
Let me again explain this thing to you. But
Yeah.
okay, you know the data, right? You know the data.
Yes. Yes.
You know the data, and you know the
Yes.
output variable, code, bankable, unbankable. Okay.
Correct. Yes.
The question is why we need to split the data. Okay. I will again explain to you. No worries.
Sorry.
Let's say no, it's okay. That's actually the good thing. Okay. Let's say here is our big data, and here is our complete data. And
Yes.
here are the new points which company told me, which company has asked me to predict these.
Okay, to predict.
These.
Okay.
Predict these. Okay. Now I have to predict these. Okay. Now the company has provided me this data. Now if I make a model, on this complete data, just listen it carefully. If I make a model on this complete data, then I have to, and if I go directly after making a model, I'm getting an accuracy of, let's say, 90% accuracy. And I've just made a model. I've not tested it. I have not evaluated it. I've just made the model, and I just go directly on this data, which company has asked me to predict. And let's say if it gives me
Stop there. Quick one, stop. You said, okay, you have a complete model. The model is based on what? That 90% is based on what? What's that 90% based on? That's why I'm confused.
where
That 90% you're putting there, you put, let's say, complete data, you created a model, and you're required to predict. On the data itself, on the right, they put model 90%. What's that 90% based off of? I don't understand. That 90% you put there, I don't get it. What's it based off of? Do you understand my question?
Okay, I need to, yeah, I understood it, but I need to make sure that okay. Let me put it this way. I have to explain you this concept because it's a machine learning concept. I thought that I would be teaching you the machine learning. Will be explaining you this thing till depth. But okay, let me do it right away. Here's the information. Here's our status output variable. Okay. Now the thing is, this is our status. Good, bad, good, 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 bad. Okay. Now we have made a model on this data. Okay.
Yeah.
Made a model on this data. Now we will ask our model to predict this status for this model again, for this data again.
Okay.
Are you getting it? Because we want to check if our model is giving us like the same answers or not. So model will predict that it's a good, it's a bad, it's a bad, it's a bad, it's a good, it's a good, it's a bad, it's a good, it's a bad. Are you getting it?
Okay,
Don't get
got
confused.
it. Yes, I get that now. Yes.
Yeah.
I get it now.
So there will be some errors, right? There will be some errors. Are you getting it?
Yes. Yes.
There will be some errors. There will be some errors that our model will be giving. So we need to minimize those errors. A modeler has to minimize the errors. To get minimize the errors, to get the maximum accuracy, to get the better accuracies. Are you getting it?
Got it. 100%. I get it now.
Yeah. So we need to minimize the errors to get let's say after predicting this thing, we are getting a 90% accuracy. Okay.
Got it now. Yes, now I understand.
Now we have made the model. We are just directly putting it on this prediction, which the company needs. Now, when the new points, because these are the new points, right? And now the new points come and the model's accuracy is 55%, let's say. So I'm just telling that we don't need to build, we don't need to directly go to the main action area. This is the main action area where we have to
Yeah.
predict. Don't need to directly go to the main action area. We have to build our model and we have to test our model again and again in that data. Test our model again and again to get the better accuracy, to minimize the errors, to get the better accuracy within that data, within this data,
Yeah.
within this data only. And as we get
Yeah.
the maximum accuracy and we get the minimum error, then we go to the prediction, the main action area. After we
Yeah.
have made our model, we have tested our model, we have evaluated our model completely 2 or 3 times
Yes.
by hitting in trials and everything. After we
Yes.
are informed that yes, now our model is good to go. Now we move. Now we just put the new values in our models and then it predicts. So we don't need to directly put our model to the new data points. We have to test our model within this data point. So we process is we split our data here. We split our data
Okay.
in the ratio of 60% to 30% or 80 to 20%.
Okay.
Now this is our training data set on which the model is built. Are you getting it?
Yes.
And this is our testing data set on which the model is tested. Are you getting it now?
Yes.
Yeah. And the modeler needs to make sure that there should not be much difference. There should not
Okay, understand.
be much difference. There should not be much difference between training accuracy and testing accuracy.
And test the accuracy. Okay, I get it now. Okay.
Otherwise, if the training accuracy, because we are making our model on the training accuracy, so training accuracy will be good, but if we are putting this the testing data on the model, it will obviously be lesser. Yes, but
Yeah.
but
Yes.
the difference should not be much. The difference should not be
Correct.
much. We need to
It's small.
minimize
It's
that
small variant. Yes.
Yes, small variance. That's a very good
Mhm.
word that you have put. We will be coming this small variance. This is a very important word. I was just about to speak it and you just spoke it. That's really good. So there should be a small variance. Are you getting this thing now?
Yeah.
Yeah, I'm understanding now. Yes.
Okay, so that's actually the machine learning, and there are many things to it. We will be learning about machine learning. We will be using certain algorithms which are run on the training data to make the models. There are around 4 to 5 algorithms which we will be learning, but when we will be doing machine learning.
4 to 5 what? Say again. 4 to 5 what?
Algorithms, machine learning algorithms.
What
Methods.
sorry, spell it. Spell it. I don't understand. Spell it.
Machine learning algorithms.
Hello? Algorithms.
Algorithms, yes.
Algorithms. Okay, got it. Yes, algorithms. Yeah, I get it. Thank you.
Algorithms. Okay.
Algorithms. Yes, got it. Got it. Got it. So this is how algorithms are tested. So they just basically they use a sample of so it's always split like this. So depending on regardless of whatever it is you are, for example, this one was banking. So you have the data. Every customer puts in all their data, their information to help the bank know if the customer is good or bankable or not bankable. So basically, in terms of this algorithm, so we split it. You split it into. You can split it into 2. And basically use a small pool, like 30% of that you test to kind of see if it's if the predict, if it's able to predict how, I'm trying to say it out. I'm trying to make sense of it, but let me see. So you use a pool of 30%, you split it, you test it, see its validity to see how accurate it is, and based on the results, if it has a small variance, then you know it's very close to being perfect in terms of accuracy in predicting the likelihood of customers. I'm trying to make a story out of it. You understand? I get what you're doing, but I'm trying to make a story out of it.
You're very close. You are very close. The words that
Yeah.
you are using, likelihood, the words that you are using, estimates, these are
Yes.
very important words, and you are very close.
Yeah.
The thing that
Yes.
you are explaining, you are very close.
Yes.
Just keep
Yes.
on saying this. Just keep on. Go ahead. You say.
Yes. Yes. So predict these new points. So this new point you're mentioning, that area of the new point. So we tested the data. We used 30% of the data to test to see, okay, how accurate the whole pool is. Because, you can't test the whole thing, but you take a sample of it, you test it to know how accurate it is. And so the part of the predicted, you said that the 55%. So Kobe, I'm in the lesson. I'm coming, Kobe. I'm coming. So predict this new points. Sorry, hold on. Predict these new points. 55%. So when you say, like, for example, in the bank, when they say you should predict, you're predicting for when they say predict, I want to understand what they mean by predict. Are you predicting meaning like, okay, is it like a forecast? Okay.
New
Maybe
points.
the customers. Sorry.
New points. Like this.
When you say predict, I want to understand what you mean by predict, because I'm quite confused by that predict. Predict could be, is it new customers that are coming in? Predict people that have applied already?
Yes.
That are already applied?
Yes.
Okay.
Okay. Let me make another data set for you. You are asking very good questions. You are asking very good questions. These questions, very few people ask. Let's say there are many things. Now, there's predictions, not predictions, this is status. You are asking each and every question related to machine learning. I think that we need to start with the machine learning first rather than doing the Python. But we have to start with the Python.
Yeah.
And I'm already seeing that you are asking two depth questions. That's very good. Okay. Now that's the status, let's say. Okay. Now let's say that's a customer ID A1, name Sam, your name. Let's say there's some income, and then let's say their status. That's a good question. All right. That's another customer name B2300, Harry, and then there is some income. Then there is, let's say it's a group person. Now, let's say there are many data points. Now, new customer. In the new customer, when the model will be made on this data, when the model will be made in this data, and this data is splitted, and that's a training data set on which the model has made, and that's a testing data set on which the model has been tested so many times, and we have got an accuracy of 80% with the testing. Now, if a new customer comes of, let's say, CN3102, his name is Nick, his income is something, and we have to predict the status based on this model, based on this information, based on this info. It will predict based on this info, based on the info of the given data, whatever info the Nick is giving me, it's predicting good. Are you getting it?
Yes.
Yes, that's it. Because all the informations will be needed, like all the information will be same. These are the informations. Only the prediction is to be made based on this data. Let's say Harry has an income of $20,000, and let's say his interest rate is 12.5%, and let's say something, and let's say the Nick also has similar income, let's say $18,000, 12.5%, and he also has the similar information. So it will be predicted uh, as per the model. Are you getting it? Similar information.
Yes.
So it will be predicted
Okay,
similar.
okay, I see what you're saying now. So basically, some information different people are putting will be similar in terms of okay, their income
Information.
bracket. Okay, I get it.
Yes.
Keep going. I understand now. I understand now.
So the information would be similar. The information variables, the features that we are using. These are the features that we are using: name, income, and whatnot. There are many things. So then only this thing is unknown. Only this thing is unknown, and we will just give all these features as an inputs to the model that we have made,
Yeah.
and the model will give us a prediction, good or bad.
Yes. Yes, got
That
it.
will take a very less time. That will take a very less time. I hope you're
Yeah.
getting it.
Yeah. Sorry, hold on. Sorry, 1 second. Sorry. 1 second. Sorry. Give me a second.
Yeah.
Somebody's calling. Let me just send a message so they don't spoil my class. Sec. Babe.
Let me drink some water. Your questions were really
Sure.
good.
Sure.
Yeah.
Thank you. I really understand it now.
There are much more questions. And I want to predict, and I'm right now predicting what your next question will be. Okay. I hope you're getting it, right?
Yes, I am. Yes, I am.
You're getting a call. Have you attended the call? Should we continue?
Yes, I have. I was sending a message. Sorry. Yes.
Okay. You can
Yes.
take the screenshots of all these things. Okay, I'll send you all these things and try to spelling. Like, I just want to ask you. I just want to know how my handwriting is. Can you understand it?
Yes, I can. I can.
I hope you can understand it.
Yeah. So yeah, that makes a lot of sense now. I get it better now. So
Yeah.
basically, a lot of customers that are putting their input, a lot of the information is similar. So
Yeah.
based on that, it's able to predict the likelihood of the end result of the output based on a combination of different information that other people who have failed or have passed have done. So it's basically, yeah, I get what you're saying. I understand now. It makes a lot of sense. But my only question is that for like how we made mention of banking, yes, I guess it makes sense. But usually, depending on the type of system that this is being used, this machine learning tool is being used. Like for banking, it makes sense. Can the same thing be done with other scenarios? For example, like maybe insurance, maybe in terms of if you're applying for credit for a credit card, for example, it can be used across the board, or or is it that there's some more information that you might be required to input for it to come up with a final result? I don't know if you understand my question.
I've got your question. I want to show you a data. Please give me
Sure.
2 minutes. Insurance claims data. So, that's in insurance claims. Can you see it? I hope you can see it.
Yeah, I
You
can
see
see.
it?
Yeah, I
That's a
can see it.
driving. That's insurance claims data. So it's asking for. There's one more data with it. I'm not getting it, but that's the more irrelevant data. Okay. So that's a claim ID that's given. That's a customer ID that's given. That's an incident cost. Like what kind of error was because of what? Are you asking for
Yes.
insurance, right? Okay. Driver
Yes.
errors, crime, it's methods or anything else, other driver errors. Claim date,
Yes.
what is the insurance claim? So all these other informations, right? All these other information. What's the claim amount? What's the claim type, material type, or injury type? What was it? Was there a police report? So all kinds of information are needed. If more and more information is needed, more and more information makes our model what we call it. It gives better accuracy, right? If we have more and more information about something, then we are going to predict more closer. We are going to predict more closer to the correct value, right? Getting it. If we are
Yes.
having more and more information about anything, any situation, or any person, or anything, then we are going to predict our answer more closer to the correct answer, right?
Correct. Correct.
Now,
Correct.
there is one column. There is one column at the end. There's one column at the end. Can you see it?
Yeah, fraudulent. Yes.
No, yes, no, yes. That's a predicted thing. Now this data, just look at it. You see it. This data is already split. Can you see yes, no, yes, no, yes, no, yes, no,
Yes.
yes, no?
Yes.
Now just see, they will be gone. Just look at it, just look at it. Gone. Yeah. Can you see now they are gone? Can you see?
Yes.
These are blanks. These are blanks.
Yes. Yes.
Able to see. Now the thing is, the data which is all above this thing, in which the predictions are given. This is the training data. Now this is here. I have to predict it. This is the testing data. The testing data we don't have. That's what I mentioned there. That's what I mentioned there. Can you see? Predict the status in the testing data. Predict the status.
Correct. Correct.
So here we have to predict. This is the testing data, and it is 80-20% split, 70-30% split. Company needs, as per the industry, I don't know, maybe in your country it's 80-20 split, or maybe in US it's 70-30 split, but generally it's 70-30 split between 70-30 split means 70% training data and 30% testing data, right?
Okay, so it's 70. So is it universal is 70-30?
Yeah, as per the industry standards, as per the generalized model, to make a very generalized model.
Sure. You said so 70% is what did you mention?
I told you, right? We have to split the data. We have to split.
Yes, I know that. Yes. Okay, so the training. Okay, training data. Yes, training
70%
data.
70% training data, 30% testing data. In such a way,
is testing. Yes, testing data. Testing data. Got it. It's making a note. Thank you.
So
Got it.
I was showing you this thing because your question was really apt again, as usual, about the insurance claims and everything. In any kind of field, whether it's sports, whether it's insurance claims, whether, let's say in sports, if they're predicting, what can they predict? They can predict which sport is famous in your country?
Football.
Nigeria. Football.
Yes.
Football. Okay. They want to predict a win or lose, right?
Yes.
They want to predict a win or lose. Oh, wait a minute. Nigeria has a football team, right?
Of course. Yes.
And they also appear in FIFA.
Yes, of course.
Oh, that's right. That's right. Yeah, obviously then. Okay. Football must be very famous too.
Yeah.
So yeah. Okay, so we will be predicting win or lose for any two teams. Like let's say any two. I'm not very much familiar with the football. I mean, I watch it, I play it, but I'm not very much familiar. Can you tell me the names of any two teams who's like the rivals, like who have been playing since long, and their
Okay. Say.
number of
Okay. Say.
matches?
Okay. Say. Okay. The one. Say Arsenal and Manchester United.
Yes, let's say Arsenal and Manchester United. Oh, Arsenal is good. Manchester United is all good. Also,
Yeah.
Ronaldo is not at Manchester United, right?
No, he left. He's left.
He's in Juventus right now. No, he has
No,
left
no,
that
no.
also.
He's in Saudi Arabia.
He has went to Saudi Arabia.
Yes.
When did that
Yes.
happen?
That happened like
Few weeks
7 months
ago, I
ago.
think.
Like it was in Jan. It was in January. In January.
January.
January. Yes.
Okay. And what about Messi? He's also going
Messi.
to Saudi.
me-
Like he was
Maybe we don't know yet.
felicitated at the FIFA event, final event.
Yes, he might be going to Saudi, but he's still in. He's in France. He's in Paris Saint Germain at the moment. PSG. Still in PSG.
Oh, okay. All right. Let's say Arsenal versus Manchester United, and we get the data of Arsenal versus Manchester United. We get the
Yeah.
data in such a way like players' information, who are the best players, how many kicks they have, how many, what we call, what's that? Ace? Is that penalty shootouts, or how many kicks have they converted?
No, how
How
many
many
goals?
passes
How many
have
goals?
they?
Based on goals. How many goals? Goals.
How many goals have they scored? How many passes have they?
Yes.
Like this
Yes.
thing,
Yes.
and all the
Yes.
data
Yes.
is informed. How many? What's that? That's a very important data. Hold percentage, possession.
Possession. Yes. Correct. Possession as well.
Possession.
Yes. Correct.
So
Correct.
all those informations, or all those features can be used, and there must be like let's say these two teams have been playing for like last 50 years, and then all the informations will be given like win or lose, win or lose, win or lose. For a, let's say if it's a Arsenal, if you are an Arsenal data analyst, so
Mm-hmm.
here is the prediction. Here's the status for Arsenal: win, lose, lose, win, lose, win. And you have to predict for the next 10 matches, or you have to predict for the next year. Then, in
Yeah.
that case,
Yeah.
sports, like in sports as well, data science is booming right now, and machine learning
Yes.
models are our favorite right now in each and every kind of field. So, whether it's insurance claims, whether it's loans, bankings, financial sectors, stock markets, sports, and e-commerce sites, obviously, like Amazon, they have to predict
Mm-hmm.
like their
Yeah.
prices. They have to predict
Correct.
which is
Correct.
which customer is very good, which customer is loyal, which customer is not loyal, like that. So in each and every
Yeah.
field, machine learning is required. So yeah. So we will be looking at it, and tomorrow